Hello everyone. Previously we were done with the string based algorithms, right? So the last one was edit distance using the Wagner-Fisher algorithm, DP algorithm, right? So now today we'll be starting with the sorting algorithms, right? So first we'll be starting with merge sort. So let's get into the definition part now. So what does the definition part say here? Merge sort is a divide and conquer. So this is fine. Just remember this word. Merge sort is a divide and conquer comparison based sorting algorithm, right? So this is divide and conquer comparison based sorting algorithm that repeatedly splits the array into halves, right? So whatever the array that we have given, it repeatedly splits the array into halves, sorting each half and then merges the sorted halves, right? So basically it guarantees pick of n logarithmic n time and best, average and worst cases, and is a same this one and is a stable sort, right? So meaning it preserves the equal element order, right? So let's move on with the explanation part here. So what is the idea basically? So we'll be going with the recursion, right? So what we will do, we will recursively split the list into halves until each piece has 0 or 1 element, right? Meaning already sorted. After sorting everything, so we will be left with either 0 or 1 element, right? So we will recursively split the list into halves until each piece has 0 or 1 element. So the same thing will be implementing this one in the form of algorithm or the code. So just try to understand this, right? So we'll recursively split the list into halves until each piece has 0 or 1 element. Then we will merge those small sorted lists back in order. Then what we'll do, we'll merge those small sorted lists back back together in the order. So I mentioned divide and conquer approach, right? So let's see what is divide and conquer. When I said divide and conquer, so depth of the recursion here will be big of log n to the base 2, right? So mainly, so this one is big of logarithmic n. Each level performs big of n work merging, right? So overall it will be big of n log n, right? So the time would lead to, the time complexity would lead to big of n log n, right? So this is fine. What will be the space here? Space complexity. Typical implementation, this allocate extra arrays for the merging, right? So this requires big of n additional space here, right? And it is not in place as well, right? So overall it would be big of n, right? So this is stable only if merging uses this one less than or equal to when comparing, right? So this is stable only if merging uses less than or equal to when comparing, right? So elements equal and value retain their relative order. Just try to remember this as well. So finally, let's come to the variants part here. So we can just go with the top-down recursion or the top-down recursive here. That is that will be shown while we write the algorithm or code. Finally, we can just go with the bottom-up iterative as well. This is also possible basically. Let's see. Let's start implementing the same. Whatever I have explained now, let's try to write the same thing in the form of code, or let's try to implement in the form of code. Let's start writing the merge sort algorithm. First, let's go with the merge helper method, right? So I'll just go with merge here. So this one I'll just go with left and right. So within the merge helper method, so let's create the result list and 2 pointers for left and right. So I'll just go with merged. Let me initialize this one to the empty array. Also let me initialize I to 0, j to 0. This is fine. So we are done with this, but now let's go with the while loop, meaning, so let's go with while both lists have elements remaining. We have to pick the smaller current element, right? So accordingly with what we have discussed on the approach. So this one explanation, what we have discussed on the explanation, basically this one will be length of left and j less than length of right. So this is fine. Now let's do one thing. Within the while loop, let's go with a simple if condition. If current left element is less than or equal to the current right element, then we have to append the left of I to the merged. Also, we have to move the left pointer forward. Let's see the same thing in the action. So I'll just go with if here left of I less than or equal to right of I, right of j. Sorry, this is fine. Then we have to append the left of I to the merged, meaning I can just write it on this way: merged dot append what we need to append, left of I, right, as I've said. So then we have to move the left pointer forward, I equals I plus 1, or I can just write it on this way, I plus equals 1. This is right. Now this is fine. Else what we need to do, meaning else while both lists do not have the elements remaining, then what we need to do, we have to append the right of j to the merged. So I'll just write here, where is merged? This one, not memory view, man. So why did I select this one? This one, merged dot append. So what we need to append, right of j. So I'll just go with here, right of j. This is fine. After appending the right of j to the merge, we have to move the, instead of moving the left pointer, this time we'll move the right pointer forward, right? So I'll just go with j equals j plus 1. So we are done with this part. Now what we need to do, so at this point, one of the left or the right may still have the items, right? So we have to append them as well. So we are left with only one thing, meaning at this point of time we are left with only a left or the right. One of the left or the right may still have the item. That is also possible, right? So then we have to append them as well. So let's write the same thing in the form of code. So let's check if any remaining in the left. So I'll just write the simple if condition for that. If any element is remaining in the left, length of, let me pass left here, then let me go with merged here, merged dot extend. So this is fine. So I'll just go with left of I. This is fine. Then let me go with one more if here. So this one, if j less than length of right, this is fine. Then let's append the leftover from right. So this one will be merged dot extend. This one will be right of j. This is fine. We're done with this part almost. So we are left with only one thing. So we have to return the fully merged sorted list, meaning I'll just return merged here. So again, what we are doing from line number 31 to 35 basically. So if any remaining in the left, then we are appending the leftover from left, this one, right? So the line number 33 and 34, if any remaining in the right, then we are appending the leftover from right. So this is fine. Finally, we are returning the fully merged sorted list. So this is for the merged helper method. Merge helper method, right? So now let's go with the merge sort. So let me go with the, yeah, this is fine, right? So just go with that merge sort. So this is fine. Let me pass the array as parameter. So this will be helpful on this one. What do we call? While we consider the example usage. This is fine. Let's go with the base case first. So let's go with the, we have to consider the lists of length 0 or 1 if they are already sorted, right? So let me write the simple if condition here. If length of this one array, if it is less than or equal to 1, then we have to just return the array in that case. So this is fine. Next thing is we have to split the array into two halves, meaning, so we have to go with the mid index, left subarray and the right subarray, right? So let's split the array into two halves, meaning this one mid index. Let's go with the left subarray. This is fine. And finally, let's go with the right subarray, meaning element. This one, first we are going with the integer division. Next, elements before the mid and elements from the mid onwards, right? So the same thing. Let's split the array into two halves first. So mid equals length of array, so this one by 2, this is fine. Left half, this is also fine. This one will be array of this one mid, this is also fine. Right half, this is also fine. This is fine. Now we have to recursively sort the each half, right? So one thing, just I'll just keep here merge sort. This is fine. Let me go with left half. This is also fine. We have sorted the left half. Next, let's go with the sorted right. So I'll just go with sorted right instead of the sorted left. So this one will be again, we'll go with a merge sort. So we are just recursively sorting each half, right? So we have to sort the right half now. Let me pass the right half here. So this one, right half. This is fine. Now after doing this, we have to merge the two sorted halves and we just have to return. That's it, right? So we have written the merge helper method for this, right? So I'll just go with merge here. So I have explained this one step by step, right? So I'll just make use of merge here. So we have to merge the two sorted halves and then we have to return, right? So what we have to return, basically sorted left, and we have to pass the sorted right. So I'll just go with sorted right. So we have to merge and return the result. Now we are done with the algorithm part, right? So let's go with the example usage here. So I'll just go with if name equals main, let me go with the example array just to demonstrate the merge sort here. So I'll just consider some random elements within the array. So this one will be 38, 27, 43. So let me consider some smaller numbers as well. 3, 9, some huge numbers, 82. This one 10 as well. This is fine. Now what we are left with, basically, let's go with the this one. What do we call? Let's print the original array first, right? Just for the sake of this one, just for the interactive purpose. So how can I do this? Let me go with print here. This is fine. Original. This is also fine. Let me pass array. This is also. Now let's go with the sorted array here. Sorted array. Let me pass merge sort here. This is fine. Let me pass array here. This is also fine. Now let's go with the print. Let me go with print here. This one is sorted. So let me leave space so that this looks good. So let me pass the sorted array here. This one, right? So we have to print the sorted result, right? For that one, we have to pass the sorted array, basically, right? So previous line, what we are doing, line number 54, we are just calling the merge sort and we are storing the result. Right, first from the line number 52 to 55. So 52, what we are doing, we are just going with the original unsorted array, right? So next we are printing the original array. Next line, so now in the line number 54, we are just calling the merge sort and storing the result. Finally we are printing the sorted result, right? So this is fine. So we are done with the coding part. We are done with the coding part. This is fine, man. So let me format the code once so that this looks good. This is fine. Now let's do one thing. Before running the code, or we have to get the this one. Let's discuss the output. So whatever the array we have considered here, this we have to get in the ascending order, right? So 3 is the smallest element, followed by 9, followed by 10, and 3, 9, 10, 27, 38, 43, and 82. Thus we have to get this one first in the original. So we are just printing original and we have to get this one, original array. This one has to be 38, 27, 43, 3, 9, 82, and 10. And then within the sorted, so see here, sorted, we are going with the sorted array, nothing but 3, 9, 10, 27, 38, 43, and 82. This is fine. Now we are done with this part. We are done with this part. So next, let's do one thing. We have went with the original and sorted array, right? So this is fine. Yep. Now let's do one thing. Let me run the code. Let's try to run the code. So this one here would be sorry, Control J here. So let me type Python followed by the file name. So let me come here, I copy the file name .py. So see here, original, we have to get the original array itself, right? So we are getting the same array, 38, 27, 43, 3, this one. So this one we have to get the sorted array in the ascending order. So we are not getting this one in the ascending order. Somewhere I have done something wrong. 3, 27, 38, 43, 9. So 3, 9, 10 we have to get, right? So just give me. So I see what mistake I have done here. So within the merge method, see, so this is the indentation problem. So I have placed this one within the while loop itself, right? So I just have to move this one where while loop is present, right? So this is different. Basically this is within the while loop, these conditions, if else. So this one is two different conditions outside the while loop, right? So this one I have to place here, and also return value as well. So this one has to be here. Now if I run this one, I have to get the correct output. Let's check the same. So yeah, now we can clearly see we are getting the correct sorted array: 3, 9, 10, 27, 38, 43, and 82. This one we are getting this one in the ascending order, right? Which is completely sorted in the ascending order. Now we are getting the correct output basically, right? So this is fine. Yep, we are done with this part. So basically this one original array whatever we are getting, so this is the initial array that is printed by print of original array whatever we have written, this one basically, this one line number 55, right? 54 and 55 basically, right? So it shows the unsorted input we fit to the merge sort, and this one sorted array is nothing but this is the final sorted array printed after sorted array equals merge sort of array, this one 56 and 57 basically. So merge sort has returned a new list containing the original elements in the ascending order. So one thing, note that the relative order of equal elements would be present, will be preserved basically. It will be stable if they were duplicates, right? So this is fine, man. Now we are done with the basically merge sort. We are getting the desired output and we know the algo as well, right? So this is fine. So as we are done with the merge sort, let's quickly discuss or let me summarize whatever we have learned so far, right? So what merge sort is basically, what it does, just remember these points, man. Just try to remember this one. This is very important. Merge sort basically what it does, it splits, sorts and merges, right? So it splits, sorts and merges. So it is a classic divide and conquer algorithm, right? It is completely a classic divide and conquer algorithm. So what will be the time complexity? So time complexity would be pick of n log n and best, average and worst cases. So time complexity would be big of n log n. So what would be the space complexity? Space complexity would be big of n auxiliary space, right? So since merging typically needs the temporary arrays, we know this, right? So about the stability, it is stable if implemented with less than or equal to in comparison. Again, this one I had a stress that one earlier as well. Now also I am this one stressing. It is only stable if it is implemented with less than or equal to in comparison, right? So when to use this one merge sort? So this is good for large data sets where guaranteed big of n log n is needed, right? So just remember this one. So this is good for large data sets where guaranteed this one big of n log n is needed. So this is useful when stability matters, right? So this is useful when stability matters, right? So this is not ideal when minimal extra memory is required, right? So this is not ideal when minimal extra memory is required. So about the variation, we can just make use of the iterative bottom up merge sort, or if we can go with a recursive approach as well, right? Recursive top down. So either we can make use of the iterative bottom up, or we can just go with the recursive top down. So it is better to go with the iterative bottom up merge sort if you want to avoid the recursion where memory matters the most, right? So you can just go with the iterative bottom up merge sort, right? So this is fine. Now we are done with the this one merge sort algorithm, right? So we are done with the merge sort algorithm. So previously we were done with this one string based algorithms. You can just go through it if you want to go through any algorithm, right? So we had discussed 8 important array algorithms, and previously we were done with very important 10 string based algorithms as well. Now we have started with the string algorithms. We have finished this one merge sort. Next, followed by the merge sort, we'll be discussing on quick sort, heap sort, counting sort, and the radix sort or the bucket sort, right? So next we'll be discussing on the quick sort algorithm, right? For now, this is it. Thanks for watching, guys.